Hey guys, welcome to Easy Academy. Today we're learning about combustion reactions, and what a combustion reaction essentially is basically taking something and burning it in air. And in a chemical equation, it will look something like adding oxygen gas to something. So for example, like nitrogen gas combusts with oxygen gas to create dinitrogen monoxide. And balancing this equation, so this would be a classic combustion reaction. Now if we go deeper and go into something more complicated, not every combustion reaction is like this. For hydrocarbons, which is basically compounds made of hydrogen and carbon, it's different. So a classic example of this in the real world that you might have learned in biology is photosynthesis and cellular respiration equations. Now for this video, let's use cellular respiration, and the equation for cellular respiration essentially is combines with oxygen gas to create carbon dioxide and water, and also energy on the right side of the equation, because in the exothermic equation the result releases energy into its surroundings. Now for hydrocarbons, you see that when you have a hydrocarbon like glucose, it turns into carbon dioxide and water. It doesn't combine the orthodox way like nitrogen gas and oxygen gas combining together, not a synthesis or a combination reaction, not just combining them together, but you rather create two different compounds, carbon dioxide and and water. Now for metals, there are two different types of equations that would happen. The first one would be exothermic ones, which means it releases energy. So an example for this would be 2 magnesium combines with oxygen gas to create magnesium oxide and energy. So when energy is on the right side of the equation, it always means it's an exothermic reaction because you're releasing energy in the final product. Now the other one would be endothermic, which means you're not releasing energy. In fact, you're putting more energy inside of the reactants. And one example of this would be, for example, energy on the left side of the equation combined with copper and oxygen gas to create copper oxide. So you can tell if it's exothermic or endothermic based on the side the energy is on in the equation. So if it's on the left side, always remember it's endothermic, but if it's on the right side, if you have the energy on the right side, remember that's an exothermic equation. So good luck on your tests and quizzes, guys. Peace out.
Yo, I ain't here for the money, I ain't here for the fame. Though it might be nice to own a jet plane, I'ma do it all for you. Come along and see it's true.